Welcome to my channel, my class. Today we discuss another transportation problem. In the last two classes, we discussed transportation problem with the help of northwest corner rule and least cost entry method. And today we discussed another popular method of transportation problem, solving the transportation problem. That method is also known as unit cost penalty method, and popularly known as HAM, Vogel's Approximation Method, or HAM. So let us have an example how to solve it. And before that, before going to this example, let us know penalty. Penalty means, in this case, penalty, we think of the penalty. What penalty is? The differences between two minimum costs allotted in the problem. So let us start with the problem, transportation problem number 3, Vogel's approximation, HAM, Vogel's approximation method, and hope you like it. If you like it, then please subscribe it also and share it. So let us have the slideshow, and this is the problem. So determine an initial basic feasible solution to the following transportation problem. This is the transportation problem. Here, this demand 6 plus 10 plus 15 plus 4, and supply this 14 plus 16 plus 5. This is 35, means demand and supply both are equal. So these type of problems are called balanced in transportation problem. And these values allotted here, the cost per item, cost transportation cost per item to deliver it to the particular destination. So this destination means the D1, D2, D3, D4, these are the 4 destinations, and you can think for your convenience, for your simplicity, you can think this D1, D2, D3, these are the different parts, and O1, O2, O3, these are the different origins, or you can think these are the different warehouses from which the items will be delivered to D1 or D2 or D3 or D4. Suppose item is delivered from factory 1 or the origin 1 to destination 1, then that cell, this cell will be the first cell. We call it cell 1 1. This cell is 1 2. This cell is 1 3 1 4. Similarly, 2 1 2 2 2 3 2 4 3 1 3 2 3 3 3 4. And this supply means origin 1 has 14 available items. Origin 2 has 16 items available. Origin 3 has 5 items available. Destination 1 requires 6 items. Demand means requires. Then destination 2 requires 10 items. Destination 3 requires 15 items. And destination 4 requires 4 items. Now, we have to determine an initial feasible solution, means we have to find the number of items given to particular destinations, and the total cost. So let us proceed with Vogel's approximation method. Okay, again, to apply this Vogel's approximation method, we have to see what we find some penalties row wise and penalties column wise. And these penalties are what? These penalties are the differences between the minimum costs allotted in the destinations as well as the origins. Okay, let us come to this part. So this is the given table, and from that we prepare one more table. Here you have seen this is the penalty, this is the penalty. So how do you get this 3? 3 means, let me have one, yeah, this one, this is 4, this 4, and this is 4, and this is 1. 4 and 1, these two are the minimum costs of origin 1. So what is the penalty? 4 minus 1, this 3 is the penalty. This 3 is the penalty. Then this 3 is the penalty. So origin 1 is done. Then origin 2, what is the minimum cost? 2, and another minimum cost, second minimum cost is 7. So differences between 2 and 7 is 5. We have written there 5. And similarly, differences between the minimum costs of origin 3, this 3 and 2, the minimum, this 3 and 2, this 3 and 2, these are the two minimum costs, and difference between 3 and 2 is 1. So origin wise done. Then now let us come to destination wise. Destination wise, what are the minimum costs? This 6 and 4, and what is the differences between 6 and 4? 2 is the differences. This 6 and 4, 6 and 4. This is the 6 and 4. What is the difference? 2. Then next is 4 and 3. These are the two minimum costs, and difference is 1. Then 1 and 2, difference is 1. And here 5 and 2, this is 3, yeah, this is 3 and 2, difference is again is 1. Difference is this 5 and 2, difference is 3. It is wrongly written. This should be 3. This should be 3. Hope you remember it. This is 3. Now, what? Okay, let me have these things. So we have seen, and already I have made this. Let me wrap these things. Then we have seen, we have already marked them. What? Yeah. So now what is the maximum penalty in these columns? In these columns or rows? Maximum penalty, already I have marked it 5. I marked it red. This is the maximum penalty, and for this maximum penalty is the second origin. Second origin, and what is the minimum cost in this maximum penalty? This 2 is the 2 is the 2 is the minimum cost. So 2, since 2 is the minimum cost, therefore we allocate this 2 here. We allocate this 2 here, and let us allocate this 2 here. Yeah, allocate 2, and how, while allocating 2, then how many items can be supplied to this cell is to be determined by the requirement and the availability. So requirement is 15, and 16 items are available in the second origin. So how many items can be provided there? 15 items can be provided. So let us bring this 15 here. Yeah, 15 items have been provided. Now see, since out of all the requirements of 15 in destination 2, we have allocated this 15 to origin 2 and destination 3. Therefore, the total requirement of destination 3 has been finished. So total requirement of destination 3 has been finished, and out of 16 these available products, available items, we have supplied 15 items to the second cell. Therefore, one item will still be there, which can be provided again. So we have understood this first step. Now, since we have seen this D3, the total requirement is finished. Therefore, we iterate to another column, another table, and in that table we will remove this destination 3, and we will think of the remaining destinations and the remaining origins. Okay, let us proceed to the next table. So let me erase this first. This one, yeah, and this one. So now same procedure. What are the minimum costs here? Here we have seen minimum costs are 4 and 5. So what is the penalty? 4 and 5 penalty is 1. What are the minimum costs in the second origin? 8 and 7. So what is the penalty? 1. Then 3 and 2. What is the penalty? Penalty is 1. Similarly, column wise 6 and 4. This penalty is 2. Then 4 and 3 penalty is 1. And 5, this 2 and 5 and 2 penalty is 3. So obviously 3 is the largest penalty here. So according to the largest penalty, we think of destination 4. So what is the maximum, now what is the minimum cost in destination 3? In destination 3, minimum cost is 2. So minimum cost is, since minimum cost is 2, this 2 is the minimum cost. Therefore, we assemble this 2 here. We allocate this 2 in the respective cell. So assemble. Let us bring this 2 to the respective cell. Yeah, we have brought it to the respective cell, and now we will see how many items can be provided to this cell. See, the demand is 4, and items available in this origin tree is 5. So maximum 4 items can be provided to this cell. So okay, we will provide this maximum 4 items, and after providing this 4 items to destination 4 from origin tree, therefore I think this destination 4 total requirement of 4 has been emptied. So that becomes 0. And out of 5 items, we have delivered 4 items. So 1 item will still be there, which can be provided to the next cell. Okay. So this here, we have seen destination 4 has been completely finished. Therefore, we now think of destination 2 and destination, destination 1 and destination 2. So in destination 1 and destination 2, again we will follow the same procedure. Okay, let us go to this step. Okay, then let me remove this. Yeah, this one. Then uh, we will think of what this destination 1 and destination 2, and these are the remaining supply and these are the remaining demand. And again we will prepare another table with penalty. So let us see the penalties. Penalty, there are two costs only, 6 and 4. Definitely the differences between 6 and 4 is 2. This is the penalty here. And 8 and 9 penalty is 1. 4 and 3 penalty is again 1. Again 6 and 4 penalty is 2. 4 and 3 penalty is 1. Therefore, we have seen there are two same largest number, 2 and 2. In this case, we can assume any one, either this 2 or that 2. Suppose we assume these 2. So if we assume these 2, then we think of this destination 1. And what is the minimum cost in destination 1? Minimum cost in destination 1 is this 4. 4 is the minimum cost. Since 4 is the minimum cost, so let us drop this 4 in this cell. Let us drop this 4 in this cell. After dropping this 4 in this cell, then we think how many items are to be provided in this cell. Requirement is 6, but available item is only 1. So maximum 1 item can be provided to this cell. Okay. Then after providing this this 1 item to this cell, this available supply, this available number of item in origin tree has been completely emptied, and we will see total item to be supplied is 0 there. And out of 6 demand, we have given only 1. Therefore, still there are 5 demand available, and so demand is 5 still there. Then we will proceed to the next step. Next step means, say, here we have seen origin 3 is now become empty. Since origin 3 is empty, therefore we think of origin 1 and origin 2 and D1 and D2, destination 1 and destination 2 in the next step. So in the next step here, okay, before that, let me erase this part. Yeah. Then here we the same process. Here again we prepare the same procedure. What is the penalty? 6 and 4 penalty is 2, 8 and 9 penalty is 1, 6 and 8 penalty 6 and 6 and 8 penalty is 2. Wait, this penalty, this will be 2. Penalty is 2 and 4 and 9 penalty is 5. So since this penalty is 5, therefore we will say which one is the largest penalty, 5. So we think of the minimum cost in this destination 2. What is the minimum cost in destination 2? 4 is the minimum cost in destination 2. And we allocate this, here. This 4 we allocate here, and after allocating this, after dropping this 4 in this cell, then we think how many items can be provided to this cell. So there are available a number of items to be supplied in origin 1 is 14, and in destination 2 total requirement is 10. So maximum 10 items can be given to this cell. So we give 10 items out of all these requirements. And since out of all the 10 requirements have been given to this cell, therefore this demand of this part will be 0. And out of 14 items, 10 items have been given to this cell, therefore 4 items will be still available in this origin. So we will again proceed to the next step. Before proceeding to the next step, let us see is there any empty supply or demand? Yes. In D2, this demand is empty. Therefore, we think of only D1 and origin 1 and origin 2. Nothing, no one has become empty. So let us proceed to the next step. Next step is what? Proceeding to the next step, we see destination 1 and origin 1 and origin 2 are there. Since there are only one item available, so we need not have to find the penalties. We simply find what? We simply find the minimum cost first. Which one is the minimum cost? 6 is the minimum cost. Since 6 is the minimum cost, and how many? Since 6 is the minimum cost, therefore, okay. Before that, again, let me erase these two. Erasing these two, then we have seen the 6 is the minimum cost, and how many demands are there? Demand 5, demand is 5 there, and supply means available number of items is 4. So we can give 4 there. Therefore, let us drop. Okay, this one. Here you can directly go 6, and this one, say some steps are actually done wrong. This 6 has to come first, and if 6 comes, then this out of this 5 demand and 4 availability, we can provide only 4 items there. After providing 4 items, then this demand of destination 1 becomes what? This becomes okay. This becomes 1, and we can give this 1 item to this 8, and by this way we have seen the total demand has become 0, and total supply has also become 0. Here, and by this way we have come to the end of these steps. Now we simply go to what? The allocated cells. These are the allocated cells, and we will write the initial basic feasible solutions. This x11, this 4, then x12 means this we have seen origin 1 and origin destination 2. This number of items given is 10, so this is x1 to 10, and wait, let me use another ink. This origin 10, then similarly this is destination origin 2 and destination 1, so this is 2 1, x21, x21 is this 1. Then x23 is this, x23 is this 15, x23 is this 15. We have got it. Then x31 is 1. This value is x31, so x31 we have got this. Then x34 is 4, so we have got these values. Then we will do what? We will find the total cost. So how to find the total cost? Very simple. These are the values written in brackets are the costs per item, and values outside the brackets in these special cells are the number of items supplied to this cell. So what is the cost of this cell? Cost of transportation cost of this cell is what? 4 into 6. Similarly here 10 into 4. So we keep on multiplying these non-bracketed these values and bracketed values, means and we add all these values, we get the total transportation cost. So this is the total transportation cost, and after simplification we have got rupees 114. Hope you have understood it, and if you like it, then you please share it, subscribe it, and then keep tuning to this channel. Thank you again.